Welcome everyone to Knox Game Design for December 2025. My name is Levi Smith. This month I'm going to be talking about designing and implementing a turn-based real estate game. Here's an overview of what I'll be talking about. First of all, this is probably not for beginner programmers. The reason being is that there are multiple states in this game with multiple loops and modes. The thought process I used was building one to throw away. I've actually implemented this a long time ago, never finished that game, so this time I was able to make a complete turn-based real estate game. And I always think back to the book that I read when I was in college called The Mythical Man Month by Fred Brooks, and one of his quotes was to build one to throw away. So make one, learn from your mistakes, and then you can make a better one later. First of all, you'll probably want to create a list of rules and requirements. This is based off a very familiar board game, so I'm not going to say the name of that game, but I'm going to be using the same rule sets just with different names. So the first thing you want to do is to get the basic gameplay working first. Then after that's working, you can work on the graphical display and interface and things like that. You can implement this in any order, design it in any way you want. I'm just offering the process that I used when I was creating this. And once you start working, if you do a game like this, you'll probably have revisions while you're actually creating the game, so your design may change during this process. So first of all, I started out making a class diagram in UML to just map out the classes that I'll need to implement this. My implementation is going to be in MonoGame using C#. One of the reasons I like MonoGame is that it's free. You can go out and download it and use it without paying any licensing or anything like that. And you can get a Visual Studio compiler for free as well. You just have to have a computer with Windows on it. So I used a program called Dia, which I've talked about in the past, to do these diagrams. So this is my initial class diagram for this project. First of all, we're going to have a game manager that just kind of holds all the game objects. It just has a reference to everything in the game. So the first game object is going to be a player. We're going to have multiple players in the game. We're going to have a board, and the board is going to have multiple spaces. And one design decision that I had to make, which I'll talk about on the next slide, is having a linked list. So the space has a reference to the next space. And a space also has a reference to this property called property, but it's a property as in a real estate property. And so this property is going to have a name, a purchase price, a rent value, rent for a different number of houses, rent for the hotel, a house price, hotel price, mortgage value, the number of houses, the number of hotels, and then it's going to have some methods. One is purchased, another one is get property owner, which returns a player object. You're going to have a method called purchase property, and then you pass in the player that's purchasing that property. And then you'll also have a purchase house and a purchase hotel. So this is like a very high level design. And also you're going to have a die, 2 dice, and a dice is going to have a rolled value, which is an int. So I have like the connections between these classes, like a player rolls a die and the player owns property, but a space also contains a property, but not all spaces are required to have a property. You have some spaces that don't have properties. So the class diagram helps just try to get this straightened out in your mind. So here's some of the design decision. I decided to do a linked list of spaces instead of an array. An array would have made it more complex when you're looping around. So you got a board, it's just a big square, and you move around in a clockwise direction. So the nice thing about a linked list is if you roll a certain value, you just keep going, iterating for that number of spaces. So when you get with an array, you would have to do something at the end of the array to loop back to the beginning. But with a linked list, you don't have to worry about it because it's all circular. It comes back to the beginning. So I got purchase methods, returning the Boolean, success and failure. So if you try to purchase a property, you don't have enough money, then that would return a false value. But I could have used exceptions and error handling. That might have been a more elegant solution than returning booleans. The player has a reference to their current space. That is a design decision that I made. Could have had spaces having reference to the collection of players on that space. So that's kind of just a decision you have to make. Not saying one way is better than the other. A player has a collection. It's actually a list in C# of purchased properties. I could have had a property have a reference to the owned player. The issue with that is multiplayers could own the same property if that's not handled correctly. So it's better to have a player own a property. So you got that one player has many properties, 0 to many properties. So the one thing is this makes looping through the player's own property a lot simpler. I found that to be the case. Finding the property's owner required looping through all the player's property, and avoid having both a property list and a reference to the owner player in a property. Do one or the other. Don't do both. And make the get player owner method in property to return the property's owner. That helps and makes things a lot easier with those helper functions. So this is a state diagram that I made before I started implementing anything. So the black circle here, that's your start position. So you're going to start turn, then you're going to roll, and you'll land on a space. So there's different outcomes. The space can maybe have no property. The space may have a property that's already owned. The space may have a property that hasn't been purchased, so you can buy that property. Or if you land on a space that is owned by a different player, then you have to pay rent. So after that's resolved, you can either go to the intern state, or you can buy houses and hotels, or you also have the option to mortgage the property. So as I found out as I was implementing this, it becomes a lot more complex than this initial diagram. So, but I'm not thinking about that right now. I'm just trying to think about just getting something that works. So this is step one in the process. And I'll be showing the incremental development steps through this in Visual Studio, in MonoGame. So the first step is just to get your spaces on the board, get the player moving around the board. I created a text file, which I loaded in as a resource with the different property names. So you'll notice there's 40 spaces on the board, and each one has the names of property. If you're from East Tennessee, you'll probably recognize these aren't roads or anything. These are actually like cities and communities. So it's a little bit different than the classic game, but those are defined here. And you'll also notice that every line doesn't have a property on it. So those are just empty spaces for now. So you want to load that list in from the file, the property names. We want to create our game manager, player, space, and property and die classes. You want to display all that to the screen. You don't want to worry about graphics. Just get it working right now. Just get something displayed to the screen. So I'm basically using the keyboard in this demo for the control. The control's not doing any game pads or anything, mouse or anything like that. So pressing R will roll the dice. So we get we have two die objects, and each one has a randomized value from 1 to 6. You want to move the player that number of spaces when rolled, and you want to set the current player to the next player when the turn ends. And yeah, so let's take a look at this real quick. So this is MonoGame right here. I'm not going to be going into a lot of the code, but I did want to show off, like here in the content, we have our content MGCB, which we can see we created like the sprite fonts and the player piece right there. And then we have our classes over here, like we have a die class, game class. Here's our game manager right here. So I'm not going to go through all this, but this handles like the dice roll and moving the player. If I did go through all this code, this talk would probably be multiple hours long. So for the sake, and I am putting all this code out in a Git repository. So yeah, just find the link to that if anyone out there is interested in the code. But yeah, basically I have the game one CS is the default starting point. Here's the die class right there, and the game manager, and then we have the player with everything that I talked about, references to the current space and the next player, and here's our property right here, and then we have our space right here. So I'm going to go ahead and run this. So this is step one right here. So basically I have the listing of all of the spaces with all the property names, and it goes from 0 to 39. Then I have all the players over here, 1, 2, 3, 4, 5, 6. We've got 6 players, and we press R to roll. So you can see I rolled a 6. So I moved from 0 to 6, landed on Kingston, and that's all it does. You roll. He moved 5 spaces. Player 3 moved 7 spaces. And just keep pressing R and just to move the players around the board. And then when you get to 39, then it loops back to the beginning again. So that's step one. Just get the spaces displaying. Just get something on the screen. Okay, here's step two. So now we're going to add money, property, and purchase date. So I updated the text file to include the purchase price for each of these properties. After the comments, I'm using comma separated values. I gave each player an initial amount of money, 1,500. So I'd made a design decision to track money as integers, not individual bills like some board games. That would make it way too complex. Like I said, using comma separated values, but you could use JSON or YAML or anything else, but that would require extra parsing code. In this step, we're going to allow the player to buy an unowned property when landing on it. The player money must be greater than the purchase cost for that property, and it must not already be owned. You want to subtract the purchase cost from the player money. You want to assign the instance of that property to the player's property collection. And we're going to add a game state enum. So we're going to have start turn, land on space, and end turn. So basically, I'll show it the example here, but basically, we're going to have the properties turn the color of the player that owns them. Okay, so here's step 2 loaded. I'm just going to go ahead and run this. So I'm going to press, you can now see we got player 1. Each player has 1,500 money, dollars, whatever you want to call it. You can see below each of the properties it has a price value. So like I land on Coalfield for player 1, 140. So we're going to press B to buy the property. So that turned green, the color of player 1, and then 140 was subtracted from the player's money from player 1. So then I can in turn roll player 2, land on Kingston. I want to press B to buy. It turned this light shade of blue. And you can see player 2 subtracted $100. So you can keep going and doing this for all of the different players. So right now, if a player lands on another property that they don't own, it doesn't currently do anything. Okay, so here's step 3. Now we're going to add rent if a player lands on a space they don't own. And we're also going to have eliminating players and also the game over state. So we're going to add rent values to the property data file. So yeah, this is just going to be another integer added to the end of each line for each property. So like here, Oliver Springs 60, 2. Down here we got Knoxville, 400 to purchase, 50 rent. Oak Ridge, 350 to purchase, 35 rent. So we're just adding an extra value. So we want to transfer the rent value to the property owner when a player lands on the property they don't own. We want to display a message stating that that amount has been paid. The player is eliminated if unable to pay rent. You want to remove the player from the game manager players list. That's the easiest way I found to handle it. Win condition, if there's only one player left in the game manager players list, then we transition to the game over state. You can test this by making a really high rent value. So I went increased it to like all rents 5,000. That way I was able to easily eliminate players from the game to test that game over condition. Remember to set it back after testing. Then when a player is eliminated, all of the properties become available again. That may not follow the rules of the traditional game. I think it may be transferred to actually the player that they owe. So yeah, here's the third step. Like I said, I'm not going to go through all the code. Basically the same classes, and I updated the properties like you can see right here. Got that loaded in. I will show like in the game class right here. Let me scroll up. This is where we're parsing the properties.txt file right here. This could be put in its own class and not in the game one. So I'm going to go ahead and run this. So just going to roll and buy some properties, some intern, roll, buy and roll. So, okay, so I have player 4 landed on Coalfield, which was owned by player 3. So player 4 paid $10 to player 3 at Coalfield. So you can see player 4 had $10 subtracted. So they're now at $14.90, and player 3 now has $13.70 because they paid to first buy the property and then they got $10 back. So yeah, you can keep doing that. Purchasing properties and collecting rent. So that's the third step. Just get purchasing properties and collecting rent. That's all. Just make sure it's in a working state. And it's kind of like an extreme programming type thing. You always want to leave something in a working state. So here's the fourth step right here is ownable properties and calculating rent. So now we're extending the properties class. So I'm going to have 3 subclasses. So I've got a property right here with a cost, a name, is mortgaged, and a calculate rent value. So that's all in this abstract property class right here, but it's going to have 3 subclasses: property residential, which is kind of like what I was just showing with the houses and hotels and rent values, and it's going to double the rent if you own the complete set in a group. We're going to have what I'm calling a property park, so you get more rent for the number that you own. And then I'm going to have a property dam, which would have been like a utility. So it's going to be calculated on a dice multiplier. So there's 22 total residential. There's 8 sets. Each can have 4 houses each. And each can have 1 hotel after they build 4 houses. There's 4 parks. Rent is based on the number of owned times either 1, 2, 4, or 8. Then there's 2 dams. And the rent is calculated on the dice roll. Calculated rent is an abstract method that must be implemented by the subclass. Testing requires controlling roll values. So yeah, so when I was testing out some of these, I had to like force the roll value to be a 5 so I'd know I'd land on a park to test that out. Using random rolls would have taken forever to land on those spaces. And the mortgage value is actually a calculated value, half the purchase price. So if you know it's half the purchase price, always, there's no need to create a separate instance variable to hold the mortgage value if you know it's always going to be half the price. That way you're not like wasting memory on, and it also reduces data redundancy. Like you really don't need to store that value if you can just calculate it. So yeah, here's like here's a little bit of code right here. Calculate rent. We're going to have the park count. Park count gets the property owner, get number of owned parks, and so we're going to return 25 times the value of math power 2 times park count minus 1. Then in the rent on the property dam is going to be based on a switch statement, getting the rolled dice values, total rolled dice values, times that multiplier, either 4 for only 1 owned or 10 for 2 owned. So yeah, here's this step. So basically you can see I changed the layout just a little bit. I did add the color, so these properties are in groups. So I got like purples for the first 2, and then the light blue for the second set, magenta for the third, orange, red, yellow, green, and dark blue. So now you can actually have the sets. You can see I added the parks here in the middle. It's on the 5th space right here. So I'm just going to roll by, intern, roll by, roll, and roll. So this is what I was talking about, like forcing your dice rolls or else it'll take forever. So yeah, you can see there, player 1 landed on the World's Fair Park, bought the park, and also Bissell Park. So now player 1 owns 2 parks, and player 3 now owns Chilhowie Park, and player 2 owns Market Square, which I consider a park. It's a park in this game. Okay, so player 1 landed on Market Square. So I put a message, player 1 paid $25 player 2 at Market Square, because they don't own Market Square. Now, if player 2 had owned more properties than that, rent would have been more. And also have the 2 dams. I have Watts Bar Dam on here and also Norris Dam. Chances of landing on those are going to be a little bit lower since there's only 2 spots. So yeah, player 1 landed on Watts Bar Dam, but unfortunately he only had $7, so not able to purchase that. But you can see over here, player 3 now owns both Oak Ridge and Knoxville, so it displays the message set owned. So it actually detects that both of these properties are owned now. So the rent on those would be double. So yeah, here's a little bit more information on that step 4. So I added a property set ID to the residential properties. That way we can track the owned set right here. We updated the property data file with the remaining property values for the different houses and hotels and things like that. So I updated the property residential calculate rent to double the rent if all properties in the set are owned by the same player. And I updated the parser to create a residential park dam based on the first CSV token on the line. So yeah, I put like this R for residential, P for park, and D for dam, because we got like 2 different types of properties being signified in this text file. Now I could have had separate text files for the dams and the parks, but I just decided to put them all in here, and really could do this in JSON or YAML, whatever. It might make it a little bit cleaner because this is just a CSV file. So here's step 5. This is the mortgage step. Like I said, you can implement these in any order. This is just the order that I did. So I tackled on the mortgage and unmortgage. So we need a separate game loop for selecting properties to mortgage and unmortgage. Mortgage values, you receive half the value of the purchase cost. So like I said, it's better to store that using a method, not actually stored in a variable. You want to update the rent collection code to not charge another player when landing on a mortgage property, and allow an unmortgage if the player's money is greater than or equal to the mortgage value times 1.1. So you can see here, you can select the properties to mortgage. So you can pick Clinton and World's Fair Park, Sunbright, North City, and here's the option mortgage, unmortgage. You can see right here, it's mortgage. So let's take a look at the example. Yeah, so here's step 5. Just gonna roll a couple of times, buy some properties real quick. So back to player 1, I'm going to press M to mortgage. So player 1 owns Watts Bar Dam, Lenore City, and Alcoa. So press M to mortgage. And you can see down here, I got it all on the same screen right here. So it says select property to mortgage right here. So I use the up and down to put M's beside these. So whenever it has an M beside it, then you can see up here it's changed it to mortgaged right there. Then you can go back up and say Lenore City. This is mortgage. I'm pressing U, and that'll unmortgage it so it starts charging rent again. So here's the next step: the different game modes. As you start implementing more, you can see it's like really not the best way to have everything on one screen. So I added the concept of game modes, and also this allows having a separate mode for building houses and hotels. Like I said, modes allowed to have different screens for distinct functions. You can track the current mode with the game manager. Uh, each mode implements update and draw methods. And in this new build mode, it's going to allow the player to build houses, hotels if they own all the properties in a set. You got to remember to recalculate the rent value based on the house and hotel count. And you must check that a property class is property residential, then cast it to use the house and hotel properties. So yeah, up here in the design, updated the design. So I have mode, update. I actually still have a handle input right here. And then draw method. I should do the handling input in update, but that should have its own method right there. So then I'm going to have a mode board. That's the main mode for moving around the board. A mode mortgage, a mode build, a mode trade, and a mode auction. And here's what the build mode looks like. You select the property to build, and then it shows you all the properties, and you can add houses and hotels. Then you can see it updates the screen with the number of hotels and houses right here. So just gonna buy some properties real quick right here. Now the thing is, I'll probably not end up buying 3 in a set without like trying to fix the rolls. Like if I could get player 3 to land on. Oh, there we go, Oliver Springs. So, yeah, land on Oliver Springs. I own Oliver Springs and Carnes, which are both in the purple set. So now I can go to press U to build. So now I can go to Oliver Springs and press H and buy houses. And then I can go to Carnes and buy a house and go back. So it's kind of hard to see. Like I said, at this point, we're just trying to get stuff on the screen. Don't worry about graphics. Just get it on the screen. It doesn't have to be pretty. So you can see houses 1. It's kind of hard to see. And then houses 2 for Oliver Springs. So yeah, that's all we want to do. You can see if P3 purchased Oliver Springs. And also, going back to the mortgage, you can press M. You can see now we have the mortgage on its own screen. It's not cluttering up the board screen. So step 7 is trade, and this is like a very important part of the real estate game. In order to make the collections of properties, you'll probably need to trade with other players. So on this trade screen, you need to select the player to trade with. You need to build a list of your properties and the properties that you're going to trade with for the other player, and then which ones of those are selected. You also need to allow specifying a cash amount. You need to add a yes or no option. So if one player doesn't agree to the trade, they can press no. Then modify the trade. Then restart the trade. So we want to resolve it. If both players press yes, we want to swap the properties that have been selected. Then also swap or assign the cash amounts that were agreed upon. And having this object oriented makes this really easy, because you just take the reference from one property and move it to another player, put it in the other player's collection, and take their property references and assign it to the other player, and it all magically works. So that's one really cool thing about object oriented. It makes it really simple. You're just, like I said here, you're just moving the pointers around. And I did put here that the trade screen could be a project in itself, making a good trade screen. So the one that I did is pretty simple. So the current player selects the player they want to trade with. So I've got 3 players here. So you select the player you want to trade with, and then you just press left and right to move between the players and select the properties, and then the cash amount. So here's step 7, the trade. So as before, I'm just going to go through here and start buying some properties. See if I can get... Okay, so we got now where player 1 owns Oak Ridge and player 2 owns Knoxville. So let's say player 1 wants to own both of the blue properties. So let's intern in turn. So I'm on player one, gonna roll. So now I'm gonna trade. Player one is gonna trade with player two for Knoxville. So let's go press T. Then I'm going to select player to trade. So I'm going to go to player two, press space. So this is going to bring up the list of player one properties over here, player two properties over here. So player one wants Knoxville. So I just used up and down arrows to go to Knoxville and press T to trade right there. Then I'm going to press left, and I actually got it where I got the number keys to add cash. So let's add like $250 for cash. And let's say I want to trade, like I'm going to trade North Stam and $250 cash for Knoxville. So I'm going to press yes on player one, so it checks yes. And I don't have any AI computer opponents, so everything's human control right now. So I'm going to press yes. So you can see instantly it swapped Knoxville over to player one, and it moved player one's traded property over to player two, and it assigned the cash values. So if we quit, you can see now both Oak Ridge and Knoxville are owned by player one. They're both in green. So now player one can press U and start building houses on Oak Ridge and Knoxville. Like that. So the next step that I implemented was the auction mode. So the auction allows a property to be auctioned when the player lands on a property space, if that property is not already owned. The auction has its own mode and its own interface. And in this mode, you have to track a countdown timer for the auction to complete. Whenever a player bids, then that countdown gets reset to the maximum value and the bid value increases. Then after the auction completes, then it assigns that property to the player with the highest bid. Here are some design decisions. So I made it 10 seconds to close after the last bid. That's the maximum countdown. The starting bid is 10% of the purchase price, the whole purchase price. The next bid is 1.2 times the previous bid, and these values can be modified as needed. So here's one Chihuahua Park. Here's the bids right here in the countdown. So here's the project, the next state. Step 8, here you can see like the maximum bid time right there. So let's roll. So I landed on Kingston. We're going to press A to auction property. So you can see the countdown going down right there. So we can have like each player bid. You press B to bid. So you can see these are going up by 1.2% right here. We've got player 1, 2, 3. So like I said, there's no AI in this or anything. So you just got to use up and down to go between the players and make bids. So you can see when this, so I got the bid 31 by player 3. So the countdown is going to go 4, 3, 2, 1. And then it just kicks you out. But now you can see that property, Kingston, is now owned by player 3. And subtracted that $31 from player 3's money right there. So step 9 is rolling doubles, arrested, and incarceration. So the incarceration I have here, Brushy Mountains. So yeah, if you're from East Tennessee, you probably heard of Brushy Mountain and get the reference. So you can either be incarcerated or just visiting. So when you're incarcerated, you can't move. Any spaces, if you roll doubles, you can get out or pay $50 to get out or use a get out card. So basically I made the incarceration space a subclass of the space class. The incarceration space has a list of incarcerated players. You move the player to the incarceration spot when landing on the arrested space. And then the arrested space is also a subclass of the player of the space class. You need to track when the player is incarcerated. You need to track the count of number of times the players rolled doubles, or actually, you track the number of times the players rolled doubles before they're incarcerated. Then you send them to incarceration if doubles is rolled 3 times. Like I said, here's your incarcerated options. Roll for doubles, and here's a little trick. Doubles is basically the die 1 value equals the die 2 value. That's when you roll doubles. You can pay to get out. Current player I money. Subtracts them assigned 50 if they have at least 50 money to begin with. Or you can use, which hasn't been implemented yet, the get out card. Current player I get out card. So you have to have another instance variable to player to track the number of get out cards. So you need to track whether players incarcerated or just visiting. The incarcerated loop is separate branch from the spaces loop because in the regular board mode, in the regular loop, you roll, you get the dice value, then you move the number of spaces. But like I was saying earlier, this game has a lot of different loops, loops on top of loops. So you got a specific loop just for trying to get out of incarceration, which supersedes the regular moving spaces loop. And you need to track the number of incarcerated rolls. So you only get to try to roll for doubles 3 times to get out of incarceration. Then after that, you're forced to pay the $50. Yeah, so here's step 9. You can see over here I have like the space incarcerated right there. So if you look and see public class space incarceration, then you see the colon and space. That means space incarceration, subclass is space. Here's where we call it Brushy Mountain. And here's where it like tracks all the incarcerated players and all that good stuff. Like I said, this isn't going to be about coding. This is just about the steps used to make this game. So let's go ahead and play. So the chances of landing on the rested spot may be kind of low. Okay, so player 1 was arrested. So now they're incarcerated, so they're displayed on the left side. If they're just visiting, they would have been on the right side. So now we got to player 1. I tried to roll doubles. I didn't get doubles. So the number of incarcerated rolls went up to 2. So now you can see player 1, I'm still incarcerated. So you press R for roll for doubles. You press P to pay $50, or C to use the get out card. So let's go ahead and press P to pay $50. So player 1 has $1,500. Press P. So player 1 now has $1,450, and they moved from the incarcerated side over to the just visiting side. So now they can end their turn, and now they can move as normally. Okay, so now both player 2 and player 3 are incarcerated now. Can't remember. I didn't check to see if I landed on the incarcerated spot. It might have been because I rolled doubles 3 times. So like player 3, turn. Player 2, we'll try to roll for. Okay, so player 3 rolled doubles, got out of incarceration. Okay, so this is step 10, the event cards. Like I was saying, this is not a programming project for first-time developers. So this is like a whole separate set of things that can happen. So the event card is a subclass of space. So you got an event card space. So if you land on the event card space, then you got to draw one of the event cards. And there's 2 types of event cards, which are all basically the same. They're just called 2 different things. In this game, I'm calling them happening and mystery. So you need a new event card class. For each card, implement an event card subclass. Add cards to 2 card lists based on the event type. Randomized order of the 2 list of event cards. Draw an event card when landing on the event card space based on event card type. Then each event card has an abstract action method which they must implement. And that action method is what will happen to the player if they draw that event card. So it performed that card's instruction. And this is a good example of polymorphism. So you got one event card class, but it can do a lot of different things based on which card you drew. And in this demo, I only implemented 3 cards of each type, just because in the traditional game, there's like 16 each. So I really didn't have time to do 32 different event cards. So in this step, you can see I had the new mystery. I ended up calling it happening over here. So see if I can land on one of those 2 spots. Like I said, it helps if you control the dice rolls when testing. And also, I added the get out cards. Right now, I don't have these randomized. So the first event card should be a get out card. Okay, so player 2 landed on the mystery spot. So they drew the card, Mystery Vault, get out of incarceration free. So now player 2 has 1 get out card. So player 3 is incarcerated, but they don't have a get out card. So here's player 1 landed on the mystery spot. So mystery vault, doctor's fee, pay $50. So player 1 had $14.50 subtracted. So I guess I will go ahead and show in this one. So I got the event card right here. Real estate, namespace, class event card. So it has a reference to game manager, text, card color, the card type, and then here's the public abstract action. So then I have multiple event cards implemented here. So here's one for get out of incarceration. Here's an event card for, so you're going to advance to the nearest park. So it overrides action, and then it basically finds the player's current space, then it moves them to the nearest property park. Here's another event card, go back 3 spaces. So it's basically going to go back 3 spaces. Space index, subtracting the sign 3. If space index is less than 0, then we're going to go back past the first space into the last space. So you can see, so then I got an event card 17 as another get out of incarceration. 18 is that doctor's fees, pay $50. Event card 19, bank error in your favor, so you get $200. But you see I have space event card right here. So this is where you have a event card type assigned to a space. So that's when you know if you land on a event card space, then you draw an event card and do the action of that event card. So yeah, I think it's pretty neat. I mean, polymorphism actually works. So we've implemented a majority of the game. And like I said, we've done no graphics really, just getting stuff displayed to the screen. But there's a few other spaces on the board. We got what I'm calling start. Whenever you land or pass start, you get $200. We got Sun Sphere, which is a free place to park. No action for this space. It just doesn't do anything, but we want to give it a special subclass for space, just to know that it's free space. Then we got taxes. We got 2 tax space on the board, so you're required to pay the minimum the amount specified on the space. So you can see we got the Sun Sphere here. I can show it on the demo. Yeah, so we're back in the demo, so you can now see we got Sun Sphere on the board up here. Like I said, it's just a free space to land on. We got taxes here, $75, and we got taxes over here, $200. And in the traditional game, there's also like a 10% option, which I didn't implement in this. But yeah, there I go. I rolled a 4. Player 1 landed on $200 taxes. So player 1 paid $200 in taxes, and player 1 is now at $1,300. So yeah, player 3 just landed on Sun Sphere. Nothing happened. So player two landed on tax of 75. Player two paid $75 in taxes. So at that point, you kind of have a working real estate game. It could be text based. It could be. It's just the basic minimum. So after that, you can actually start working on the graphics. So I created a display manager class, and so I'm using a model view controller approach to this. So basically, the display manager handles drawing everything to the screen. It draws all the objects. All the model game objects should not have any drawing methods. So I had to go out into all the game objects I had before, like the player and the property and spaces. I had to take out the drawing methods from those and put those into the display manager classes. And so now I have a display manager class for every game mode. It's basically separating the model from the view. Display manager has a reference to the game manager with references to all the game objects. So the display manager can reach into the view or reach into the model and pull values, but the model, the core game object, shouldn't be communicating directly from to display. I mean, if you want to do true model view controller, which I think really works pretty good in the long run. So this allows you to have different display presentations. You can do like a text presentation of the game, or you can do a 2D, or you can do 3D, as long as your core game objects are all separated from the display. So the one thing I had to do when implementing this, you have to set a target position for all the players. So I end up having like a display token objects, which has a display. You can see like the different, I kind of pulled these icons from a previous game that I made. But so basically, the model gets updated. So if the player moves a certain number of spaces, then the model gets instantly updated to the new space, but the view is going to lag behind a little bit. So you got to kind of like interpolate from the old space to the new space in the view, even though the model already has the new value. The way I think of this is like if you've seen like a movie like Top Gun with the radar, with the airplanes, the jets on the radar, and you see the little swooshing radar signal, you see the spots at the old position, then you see it at the new position. So that's kind of like the model. You only see the distinct points. But in the display, you got to kind of move from the old position. You got to interpolate from the old position to the new position so it looks smooth. So right here, I said I'm using linear interpolation from the current space to next space. This is good enough for this demo. I didn't want to spend like weeks working on this or anything. Like I said, I'm using display player token class to separate the token display from the player model data, because the player doesn't want to know anything about drawing these tokens to the screen or anything like that. Like I said, the player model position will be ahead of the token display position. It'll need to catch up with the model. And if you really want, so one problem with this, if you do a linear interpolation, if you're like at this spot right here and you want to move to this spot, you're going to move directly from here to here, which may be okay. Even if you're playing this on a real board, that's how you would move. But if you want to like move the player from space to space to space to space to space, you're going to have to keep a list of spaces you've moved and then go from each of the one space to another, which I didn't have time to implement all that. So let's go back. This is step 12. Real estate 12. Go here. So I added all the graphics and everything. I mean, it isn't perfect, but it's good enough for this demo. You see here, I have like a display folder. So I have all the display classes up here. So I have a display manager, display mode, then display mode is subclassed by display mode auction, display mode board, display mode build, display mode mortgage, display mode trade, and display mode token. So Like if you look at display mode board, so here we got all the code that was previously in the mode board into its own display mode class. So basically, it has like the draw method right here, the sprites and the fonts and the textures and things like that. So a lot of code that I wrote in here, um, which I'm not going to go through all this. This would be like 6 hours long if I go through all the code for all of this. So yeah, let's go ahead and press play. So I actually got this working this morning. So yeah, all the little tokens kind of start out here in the 0 spot, and they move down here. So I had to spend a little bit of time figuring out how to lay these spots out, but I finally got them laid out correctly. I don't know if I used the best implementation. I kind of just said, okay, start at this spot, then subtract off how in the X how far I need to go, subtract that, and subtract off all the way till I get to the end of this row. Then I had to start subtracting off the Y value. So it's kind of like one big loop to lay all these spaces out. If I had some more time, there's probably a formula that you could use to calculate directly the position of each of these spaces, which would be much more efficient. But I didn't have time to do that. So let's go ahead and press still the same controls. Like you could have multiple controls, like where you press a button or something, but I still have the text control, pressing R to roll. So you can see here, you might have missed it. The little green spade moved from start down to like Bissell Park. So I'm going to press same text control B to buy property. So I'm going to press B and it turned green. Player 1 purchased Bissell Park. So I'm going to end turn, roll. So you can see this guy moving, buy that. Roll. You can see him move over there. So yeah, player 3, the heart, moved to Bissell Park. So player 3 paid $25 to P1 at Bissell Park. So you can see P1 got $25 and P3 had $25 subtracted. So yeah, really this is the same exact game that I was just showing. But okay, so that's one where it cut corners. So I went player 6 rolled a 6 and a 6. So they went from start to Watts bar down, but it did a linear interpolation from the start all the way over here. So it cut the corners. So it isn't perfect. And they roll double, so they get to roll again. So I'll go ahead and buy that. So player 1 landed at Watts Bar Dam and paid $28. Player 6. I could just show like Sunbright, press A to auction. So the auction screen is still kind of the same. You go through here and place bids by pressing up and down like that. So it's kind of the same thing. So the auction screen could use some improvements. It's still kind of the same when it gets to 0. So player 1 won the auction right there. So yeah, it's kind of a fully functional game. This is something I'd probably show off to other people, but something I probably wouldn't put on a marketplace. So yeah, I gotta get out of incarceration free card. So player 2 landed on happening, got a card. So you see get out of free 1 right there. Like that. I don't have the display of any of the houses or anything like that yet. But it's a fully functional game, and it feels solid. This is like when I've tried to make this game in the past, I never got to this point. I'd always try to start out drawing the board or drawing the dice and things like that, which is good just to practice with. But if you want to make a fully functional, solid game, yeah, work on the model first, and then you can do the graphics on top of it like this. So yeah, just to show, like, we got Carnes in Oliver Springs. Player 2 owns Carnes. Player 6 owns Oliver Springs. So I'm going to trade player 2. I'm going to trade player 6 for Oliver Springs. Player 6, Oliver Springs. So it's the same interface here. Press T. Let's give them some cash. I want to add $50 cash. I want to press yes to trade. Go over to player 6, press yes to trade. So now you can see player 2 owns both cards in Oliver Springs. Go back. So now they're both that light blue color. You can see set owned. So now I can press U to build. So Carnes, I want to build a couple of houses. Oliver Springs, build a house. What if I'm buy a hotel? 3, 4. And then you press T to buy hotel. So if I go back, so you can see Carnes has one hotel. Oliver Springs has one house. Let's go back and build Oliver Springs. Let's do 2 more houses right here. So yeah, now it has 3 houses. Or I can go back. I didn't mention earlier. You go to build, and I can also sell houses if I'm low on cash. Press S. So now I only have 2 houses. So 2 houses. Then it automatically updates the rent right here. Carnes rent $450. Oliver Springs rent $30. That's how much another player has to pay if they land on that spot. So you can see these guys really. Oh, so player 5 just rolled doubles again and went to jail, went to incarceration. They are incarcerated. So now you can see they're incarcerated. Nice, you put it out like right here. Player 5 incarcerated. Just kind of spelled it out right there. They have no get out cards, but they rolled. Yeah, player 5 just rolled doubles, so they got out. So yeah, player 6 just landed on a happening, advanced to nearest park. So you can see that star kind of went from wherever that happening was and cut across the board to the nearest park. So let's go back and take one more look over here. What else can we do? Finish adding the rest of the event cards. I didn't add some sound effects and music. Didn't have any of that in this demo. So currently the game, if the player is out of money, they're automatically eliminated from the game, but really you should allow the player to mortgage and sell houses, mortgage properties to get that to get back above 0. That would require a loop to allow the player to do that. And also, you're supposed to build houses evenly between a property set. I don't have that condition currently set in the game. So yeah, so that's my implementation of the real estate game in MonoGame. I hope everybody found it helpful and interesting. Just a proof of concept showing that you can do a turn-based real estate game in MonoGame. And like I said earlier, if anybody's interested in the code, I'll have a link to it to the code repository, so anybody should be able to go out and download this and run it if they need to. And yeah. But yeah, I think it feels like a solid game. Just needs a little bit more bells and whistles added to it, and it would be something that I could see people playing. So anyway, appreciate everyone out there listening and watching.